So in the previous solution, we solved two-sum LeetCode problem using the brute force method, and this ran at 2032 milliseconds, which is not very optimal. So in this video, we're going to cover how you use the one-pass hash table method to solve this instead for better time complexity. So this one-pass hash table method will let you use O of n time complexity and O of n space complexity, since you only create one data structure and add the values from the array to that data structure. So the way we do this is, first we would create a hash map to store the values. And basically what a hash map does, it stores both the index and the value at that index. So first we would just go through nums, so for index value and enumerate nums. So this basically just goes to the nums list, but it keeps track of both the index and the value. So first what we'll do is we'll find the difference between the target and the value. So for the first iteration, the target is 9, the value is 2, so the difference would be 9 minus 2, which is 7. We then check if 7 is located in the hash map. So obviously currently there's nothing located in the hash map, so we would simply add 2 to the hash map and move on. The reason we would add 2 in the hash map is because later we would keep finding the difference between the target and the current value, and if 2 becomes one of the differences and it's located in the hash map, then we know that 2 and the value that we're on add up to the target 9. That might be a bit confusing, so we'll code this really quick. So basically we find the difference first, difference between the target and the value that we're on. Then if the difference is in the hash map, then we know that the value we're on and the value in the hash map both add up to the target. So we would return the index, or let's first return the hash map of difference. This just returns the index, and then let's return index. I'll explain a little more about this stuff, but we'll see what happens first if it's not in the hash map. So for the first iteration, hash map would be empty and we would be at value 2. So we would do difference equals target minus value, which is just 9 minus 2 equals 7. So difference would be stored as 7 in this first iteration. So if the difference is not in hash map, since 7 is not in the hash map, which is empty right now, we have to add something to the hash map, but we shouldn't add 7, we need to add 2. So we can do that by adding 2 to the hash map. This is how you add a value at a certain index of the hash map. So basically what this does is it adds the value 2 at index stored at index 0. So this is what happens if the difference is not in the hash map, but if the difference is in the hash map, then we return the index where it exists. That's why we use this, and then we return the index we are on. So that's how we get 0 and 1 in this case. Let's see if this works. Yeah, so yeah, we got 3 milliseconds time complexity. It runs better than 59.96%, but that doesn't really matter in the long run. If we submit it again, it might change in the runtime. Yeah, it changed to 4 milliseconds, but yeah, it's basically the same. So this is one of the fastest time complexities we can get. Not only does it use O of n time complexity, it uses O of n space complexity. We only create one data structure, which is the hash map. This is the most optimal solution to this problem.